Hello everyone, my name is Syed Asrar Ul Haq, and in this short presentation I am going to go through the dynamic partial reconfiguration. I am assuming that you are already aware about the Vivado design flow, about the synthesis and implementation steps of the normal Vivado synthesis. Now, the same flow will be for the DPR1. So where first we will synthesize all the modules including the reconfigurable modules. Then we will define a reconfigurable partition region which will hold our reconfigurable modules. After that, we will run the implementation which will implement all the configurations that we have. And then finally, we will generate the full and partial bit streams for all our configurations. Now, for the synthesis, we assume that all the design files are ready and working. So we first synthesize the entire design with a reconfigurable module kept as a black box. So suppose we have the multiple modules in our design, and one of the module we want to use as a reconfigurable module. So we will keep it as a black box. How it is done? By simply removing all the design sources from it. So there will only be the ports are declared, and there will be no design, and the tool will itself see that there is no design, so it will synthesize it as a black box. So after we have this entire design synthesized, including the black box, we then synthesize each of the reconfigurable modules separately. So in our design we have these two reconfigurable modules, the addition and the multiplication. So we will first we will have the addition module, and then we will have the multiplication module. So we will synthesize these two. So if we have multiple modules like division or a square or square root, so we will have to synthesize all of these reconfigurable modules separately. So after the synthesis is completed, so we will be having an entire system design as well as all of the reconfigurable modules synthesized. Then we will go for the floor planning. Now we have to tell the design where we want our reconfigurable module in our design. So first what we will be doing is that we will load one of the reconfigurable module in the design. So we had this entire system designed with the black box. Now we will add, let's say, the addition module in place of the black box. Then we will set this RMS partially reconfigurable, and we will tell the tool that this is the cell, this is the block which we want to reconfigure, partially reconfigurable. Now after this is done, we tell the tool that this is the region in our actual FPGA where we want this module to be added. So we will make a P-block partial block which contains all the resources needed by all the reconfigurable modules. So this is when we draw this P block, or when we floor plan this, so this is the region that will keep all our that will be partially reconfigured every time. So this is the region that will house our addition module as well as the multiplication module. So we have to make sure that the region that we will select has the resources necessary to hold these modules. After the floor planning, we will be then implementing our design one by one. So we already have this design here. So all the IPs, all the modules, as well as one of the reconfigurable module we have in here. And so we will create our first configuration. So we have the synthesized design, and we will run the implementation. So the implementation will optimize the design and place and route the design. But while placing and routing, it will make sure that this the reconfigurable module which we have the addition in here, it will be placed and routed within this RP region that we had declared during the floor planning. Now after this is done, so this concludes the implementation of our first configuration. our first configuration is ready. Now what we have to do is that we have to create a second configuration. Now for second configuration, we first have to remove this addition module and add the multiplication module in place of addition module, right? So that's what we are going to do. We will first upgrade this RM as a black box. Again, by saying that updating it as a black box means we will remove this config underscore add this addition module from our design. So it will again be updated as a black box. Uh, and we have to make sure that this region, which is known as a static region. Now why this is known as a static region is because in all our when we implement it again, when we add this multiplication module in this RP region, we only want to place and route the multiplication module, but the other modules which we have already placed and routed, we don't want that to change. So that's known as a static region. So we lock that part of the design. So after the first configuration, we say that don't, during the next runs of the implementations, don't place and route this static region again. Don't place and route these modules in the static region again. Only place and route the modules from the this RP region. So that's why we lock the static part of our design. Now after this, we load the synthesized second configuration. We already have these all the synthesized configuration available. So we load it into our black box cell and run the implementation again. Now this time, because the static region is locked, it only places and routes this RP region which contains our multiplier. Now if we have multiple configurations, we do the same thing again. Update it as a black box and load the next configuration. Again, update the black box, load the next configuration, and run the implementation, and save these implementation configurations. Now after this is completed, now there is one more thing called the blanking configuration. What if we do not need any of these modules? That we have the addition and multiplication, but sometimes we don't need either addition or multiplication. So what we can do is that we add the buffer ports to these cells, so that all the ports that connect the static region with the PR region, they are populated with buffer ports, and we run the implementation. So we can see that only the static region will be there, as well as these ports which are buffered. Now this is used to save the energy. This is known as the blanking configuration. Once all these configurations are implemented, we go on writing the bitstream. We open these configurations one by one and write the bitstream. Writing bitstream, because we had already tell the tool that we want these as a partial bit ones, so it will write both full as well as the partial bitstreams. So once all these bitstreams are generated, we save them, and then using the SDK one or the Vivado flow, we can do the DPR part. The software part will be discussed during the tutorial session. Thank you.